Welcome you all. I'm Dr.M.Tamilselvi, Assistant Professor, Department of Chemistry, Seethalakshmi Ramaswamy College. Today we are going to discuss the topic gases. Gases, as we know, are substances which are in the vaporous state of matter. In today's presentation, we are going to give some examples of vital gases which we come across in our everyday life. Later, we are going to describe the properties of gases, followed by which we are going to define the term gas pressure and talk a little bit about barometer, which is used to measure the pressure. Then we are going to discuss two important laws, namely Boyle's law and Dalton's law. Towards the end of the presentation, we are going to recognize the importance of gases and their applications. Right here in this picture, you see the chemical reaction which occurs when sodium metal is dropped into water. The huge explosion occurs due to the evolution of hydrogen gas. The Earth's atmosphere is mainly composed of nitrogen, which accounts to about 78%. 21% is occupied by oxygen. The remaining 1% is composed of carbon dioxide, water vapor, argon, ozone, etc. Though the percentage 1 is very small, it has its own role. Talking about the properties of gases, the gas particles move randomly and rapidly. The size of the gas particles is small compared to the space between the particles. And the gas particles, they exert no attractive forces, and when they collide with each other, they rebound and travel in new directions. The kinetic energy of the gas particles increases as we increase the temperature. When the gas particles collide with the walls of the container, they exert a pressure. And this pressure is defined by the term force by area. 1 atmosphere pressure is equal to 760 mm mercury or 760 torr. Atmospheric pressure is measured with a barometer, which is shown in the diagram right here. The air pressure on the mercury dish pushes the mercury up in a sealed glass tube which is inverted in the center. Depending upon the atmospheric pressure, the mercury level in the tube is going to vary, and we could read it from the graduation. Gas laws, namely the Boyle's law and Dalton's law, play a very important role. Boyle's law states that for a fixed amount of gas at constant temperature, the pressure and the volume of the gas are inversely related, which is given by the equation P times V is equal to K, which is a constant. Boyle's law, when we consider the initial and the final conditions, could be equated as P1 V1 is equal to P2 V2. Talking about inhalation, this is what happens as per Boyle's law. The rib cage expands and the diaphragm lowers. This increases the volume of the lungs. Increasing the volume of the lungs causes the pressure to decrease. As a result, air is drawn inside to equalize the pressure. The reverse happens in the case of exhalation. The rib cage contracts and the diaphragm is raised. This decreases the volume of the lungs. The decrease in the volume causes the pressure to increase. As a result, air is expelled out of the lungs to equalize the pressure. The second important gas law is Dalton's law, which states that the total pressure P total of any gaseous mixture is equal to the sum of the partial pressures of its component gases. So if there are three gases, namely A, B and C, then P total is going to be equal to PA, PB plus PC, where PA, PB and PC are the partial pressures of the individual gases. Talking about the application of oxygen, oxygen which is about 100% is used in the hyperbaric chamber, which is a vessel at a very high pressure. And this hyperbaric chamber is used to treat patients suffering from carbon monoxide poisoning and also BENS, which is a decompression sickness which is experienced by the scuba divers. The second application is about the gas ozone, which is formulated as O3. Ozone is formed in the upper atmosphere called stratosphere by the reaction of oxygen molecules O2 with nascent oxygen O. This ozone protects our Earth from harmful ultraviolet radiation. Due to the use of chlorofluorocarbons, which are termed as CFCs, there was a depletion in the ozone layer. After there was a ban in the use of CFCs in the refrigerators, air conditioners, etc., now the depletion of ozone is improving. The next important gas is carbon dioxide. Carbon dioxide is a greenhouse gas. It absorbs the thermal energy and normally radiates from the Earth's surface, and it's also going to redirect it back to the surface. However, if there is a high amount of carbon dioxide present in the atmosphere, this results in the rise in the temperature in the atmosphere. As a result, the ocean level increases and this results in severe climatic conditions. So, in this presentation, we have talked about oxygen, carbon dioxide and ozone, which are a vital part of our everyday life. Gas particles are small in size, they move randomly and rapidly and exert no attractive forces. We have stated two laws, namely the Boyle's law and the Dalton's law. Towards the end of the presentation, we have also talked about the importance of oxygen in hyperbaric chamber, the role of ozone in protecting our Earth, and we have also talked about global warming and carbon dioxide. Thank you for your patient listening.